Welcome to solverfy.
Hi there. So for this problem, we have some kind of function u of t, which is the following: r over b is sub 0, the exponential of minus r times c over the volume. So we know that r is the rate of flow of blood through the dialyzer. B is the volume, and C sub 0 is the amount of urea in the blood at time t equals to 0. Then, what we need to calculate first is the integral from 0 to positive infinity of this function. So we're going to do that. To the infinity of the function u of t. We just simply put the function here. And now we need to determine what are the of these quantities depends on the time, depends on t. And we can see that the only term that depends on t is the exponential function, which has in its argument a dependence on t. So we can just put all the rest outside the integral, and we just simply need to integrate this. Of course, we are integrating this in the variable dt, which is the only variable in here, dt. To make easier this integral, we can set that w, we can do what we call a change in variables, and then call w minus rt over b, so that if we differentiate this w, we will obtain minus r over b, because that is a constant, d of t, differential of t. So we are going to put this information up. So we can see from here that d of t is minus v over r times w. So putting that, we can see that that factor that we obtained from this differential goes away with the one outside the integral. Let me put it in this way. We can see that this goes with this and this with this. We will just have this. And we will have the exponential of w. This integral, of course, is not defining these intervals. We could do that, but we're just simply going to solve the integral and later on return to the initial variable t. So we know that the integral of the exponential is just the exponential function, so it's that easy. So we will obtain cu exponential of w, and we need to know who is w. So w is this in here. So we just put that, and we need to evaluate in the initial intervals, which is 0 to positive infinity. So we're gonna do that. W is minus r times c over b, and this from 0 to plus infinity. From 0, we know that the exponential function is just 1. So, no, first we need to, when you evaluate an integral, you first evaluate it in the upper limit, which is infinity. But when you put plus infinity in here, you could see that it is now the exponential, it is the exponential of minus infinity. And when you see the graph of the exponential function, which is this, when we go to minus infinity, this function tends to be 0. So that's 0. And that is minus, we know that is the evaluation in the upper limit minus the evaluation in the lower limit. So we'll take minus e of 0, because that's the lower limit. And this signs cancel, and we'll take CO, the exponential of 0, and we know that the exponential of 0 is 1, because in here it is 1, and we'll obtain the constant b to 0. So when we are obtained is that the interval of this function gives us the amount of urea in the blood at time 0. So that's the maximum amount of urea you can extract for blood. So that is the interpretation of this integral. Amount of urea at time t equal to 0. So that's the amount of urea, the initial amount of urea. So we have extracted all of that amount of urea when we times the time to infinity, because that's the maximum we can extract from blood. Thank you.